when small celestial bodies approach large ones. When a small celestial body approaches a massive one, it can be torn apart into fragments due to the immense tidal forces exerted by the larger body, ultimately leading to its disintegration. This limit, known as the Roche limit, defines the distance at which this tearing apart occurs. As early as 1850, French astronomer Edouard Roche discovered this phenomenon while studying Saturn. He found that when a massive satellite comes too close to Saturn, it is pulled apart by Saturn's enormous tidal forces and continues to orbit the planet until it forms a planetary ring. By using the Roche limit formula, he was able to calculate at what distance these aggregated bodies would be torn apart by tidal forces. It is precisely because several celestial bodies have come into contact with Saturn's Roche limit that they were shredded and disintegrated, evolving into the bright rings of Saturn. The Roche limit is also divided into two categories, the rigid body and the fluid body. Taking Jupiter and the Sun as examples, calculations show that Jupiter's Roche limit for rigid bodies is approximately 890,000 kilometers, while the Roche limit for fluid bodies is about 1,710,000 kilometers. This means that if the distance between the two is less than 1.71 million kilometers, Jupiter's atmosphere would be pulled away by the Sun's gravitational force. If the distance drops below 890,000 kilometers, Jupiter would be completely torn apart into fragments by the Sun's gravity. In the Earth-Moon system, the Moon's gravitational influence causes the Earth's oceans to experience tides. However, compared to the Moon, Earth is the more massive body. The Roche limit between the two, calculated for rigid bodies, is about 13,500 kilometers. If the distance falls below this value, the Moon would be torn apart by Earth's gravity. Some of the fragments would crash into Earth, while others would gradually stabilize around the planet, ultimately evolving into a planetary ring belonging to Earth.